Hello friends, welcome back to Quality Magnify India. Myself Deepak Kumar Samal. Welcome all the subscribers and viewers to my channel. We are continuing with API 653 courses. We completed already part 10 and today we will learn about part 11. In our last slides up to part 10, we covered API 650, API 653 and API 651 cathodic protection. Today we will talk about and highlighted the important points, the important questions which will come for API 653 exam, and we will cover today API 652. As I told you, API 650 is the construction, 651 is the cathodic protection, 652 for the lining, 653 for the inspection. So it should be read. If somebody want to read it, they can read it in a such sequence. Okay. So first is to understand how to construct a tank. Then after construction of the tank, how to protect the tank. Protection of the tank from corrosion is very important. So protection of the tank can be done by two ways, either by cathodic protection or by providing some lining. This lining can be metallic or non-metallic, and then we proceed after we provide the lining and we set some of the inspection frequencies. I hope you remember still the inspection frequencies. Okay, internal inspection, external inspections. What are the frequencies? Already we read it in API 653. If you didn't remember that, please visit the previous videos for API 653 and watch those, because you will get guaranteed questions for this frequency of inspection with some calculations. Okay, open book questions will come. So as per that, we will check the tank, and if there is anything, then we can do the repair. Okay, as per API 653. Repair, alternation, reconstruction, relocation. Okay, that is API 653. So today we will talk about API 652, which is lining of tanks. How we can do the lining. Cathodic protection, already we came to know the highlighted points, okay, which will come in the exam. And today we'll continue with API 652, lining of above ground petroleum storage tank bottoms. I highlighted those points which are important, and we can expect, the highly expectations is there for those highlighted points to come in the exam. As I told in earlier slides, API 651 cathodic protection, 4 to 6 questions will come in the exam. 2 questions in open book and 4 questions closed book. Similar, API 652 lining of above ground petroleum tank also, 4 to 6 questions can be expected, with 2 questions as one or two questions as open book, and rest of the questions as closed book. So the scope of this document, when we read some document, we have to go for the scope, then some terms and definitions, then able to know what type of lining is available, why corrosion happen, how to apply the lining, procedure of lining, and after application of the lining, how to do the inspections, and then record keeping. This is the way to read a document. Okay, scope, terms, definitions, then procedure, how to do that, then what are the reasons why this corrosion happens, then what are the inspection factors we have to measure, and after inspection factors it is done, then we have to go for records. Okay, so we will read this document accordingly. So the scope of this document is the recommendation practice provides guidelines on achieving effective corrosion control in above ground storage tank. I told you yesterday what is above ground storage tanks in API 651. Okay, for the cathodic protection. So this is the above ground storage tank. Already we discussed the definition yesterday. I will not repeat it again, because sometimes in closed book questions or open book questions they ask such type of definitions. So the lining is telling the same thing: to achieve a effective corrosion control Cathodic protection also same, effective corrosion control. Lining also same, effective corrosion control in above ground storage tank by application of tank bottom lining. Yesterday I explained about the cathodic, how for the bottom they do the cathodic protection. Okay, if you remember what is release prevention barrier, I have explained to that. Similarly for the lining, for the tank bottom lining, they put some lining materials in order to give an additional corrosion protection. It contains information pertain to the selection of lining material, surface preparation, lining application, cure and inspection of tank bottom lining for existing and new storage tanks. If there is an existing tank which is already in service and we found the bottom is corroded and there is no provision to do the cathodic protection, we have to go for the lining. But lining can be decided depend upon what is the tank bottom material, how the surface preparation was done, what is the lining application I have to do, and most important, the curing. Curing is very important because if you will do something, do some lining application on one of the tank and it is not properly cured. Cured means bonding, how secured it is attached. If the bonding is proper, then there will be no detachment. So that is called curing. So curing happened when curing depends upon certain criteria that we will read in next slides. Temperature, humidity, okay, application method, thickness of application, whether you properly follow the manufacturer recommendation or not. So those things if you will follow properly, then the curing will be done in a proper way. So, and inspection of tank bottom lining for existing and new storage tank. In many cases, tank bottom lining have proven to be effective method of preventing internal corrosion of steel tank bottoms. So this code usually they ask in closed book questions. White metal blast cleaning, it is SSPC SP5. One thing I have to tell you, usually what happens, here we are using API standards. That's why all the blasting and coating standards is from NES. Don't confuse yourself with NES and Bgas. Bgas is a British standards. NES is an American standard. We are reading about API, which is an American standard. That's why all the reference of blasting and painting will come from NES. We have to put some lining material, so we need to do blasting. For blasting, SP5, SP10, these are the blasting grades. If you remember, Bgas, there is SA1, 2, 2.5, 3 like that is there. Here it is different. There is a comparison chart. You can go to the comparison chart if you are a Bgas qualified or you are familiar with Bgas standards, then you have to go to the compare chart and find out what is SP5, SP10 and PA6, PA8, okay. So now we came to know the scope. The scope provides guidance on achieving effective corrosion control in above ground storage tank by application of tank bottom lining. So we'll understand some of the definitions, okay. Corrosion, the chemical or electrochemical reaction between a material, usually a metal, and its environment that produce a deterioration of the material and its properties is called corrosion. This one time they ask in closed book question. Sometimes they ask some of the definitions in closed book questions, so we need to be careful for that one. Concentration cell, an electrochemical cell, the electromotive force of which is caused by difference in concentration of subcomponent in the electrolyte or electrolyte containing different substances is called electroconcentration cell. The difference leads to the formation of discretion cathode and anode regions. Differential alternation cells, epoxy, fiberglass reinforced plastics. I put it for your info. You can read it. Okay, these are not so important, and we don't find any much questions in the exam. Okay, holiday test might be, you know, if there is any painting inspector watching my videos, might be then know this holiday test. Holiday test is a discontinuity in a protective coating that expose unprotected surface to the environment. Okay. Holiday testing, they're using usually a sponge and soap water, and then they will use an electric medium to check it. If there is any paint loss and it touches the metal surface, then it will give a beep sound. So that is called holiday test. Mills, this mill is for your knowledge, okay. 1,000 of 1 inch is called mill. 1 by 1,000 is called 1 mill, okay. Because we have a thin lining and a thick lining. To understand that one, you need to understand what is mills, okay. So 1 mill is equal to 25.4 micron. It is common practice, use 1 mill is equal to 25.5 microns. Mill scale, that is important, okay. Mill scale you should know. There is a question for mill scale. There is a closed book question scale. The heavy oxide layer formed during hot fabrication of heat treatment of metals, typically a black blue colored smooth layer found on the surface, is called mill scale. Mill scale is not a corrosion. Mill scale itself is cathodic. As I told you, cathodic means it will not corrode. If it is anodic, it will start corrode. It will start degradation, okay, degrading the metal from anode only, not from cathode. So mill scale is the heavy oxide layer formed during hot fabrication. When, if you know about the plate formation, they put the molten metal in the ingot, then from the ingot the rollers are there and the plates are rolled, and they will come to a standard shape. Thickness, how much thickness of plate you need, its rolling is going on till you reach that thickness. So during that rolling, which we call as hot fabrication or heat treatment, PWST, post-weld heat treatment, typically a black blue colored smooth layer found on the surface, and that is called mill scale. So black blue colored smooth layer is found on the steel surface, which is called mill scale, okay. Then it is not so important, you can read it for your knowledge. This is a question most of the time they ask, as I told you in the last slide, thick film lining and a thin film lining. You have to remember it, there is a closed book question for this one. A lining with a DFT, dry film thickness of 20 mils or 500 micron or more is called a thick film. 1 mils, as I told in the last slide, 25 micron. So 20 mils is 500 micron or more. You have to remember this more word, okay. They will write thick film coating is 20 mils or 500 micron or less. No, this is more or more. Either it is 20 mil or more is called thick film lining, and thin film lining is less than 20 mils, okay. Volatile corrosion inhibitor, VCI. VCI usually a corrosion inhibitor, they add it, and by the time it inhibits, means its life will go. We will read this one. A type of corrosion inhibitor that is used to protect ferrous metals or non-ferrous metal against corrosion or oxidation, where it is impractical to apply surface treatment. Surface treatments, if it is not applicable, you cannot do the surface treatment due to any reason, safety reason or some of the constraints, or equipment cannot go there. At that time you apply VCI. It works by slowly releasing chemical compounds within a sealed airspace that effectively prevents surface corrosion. So what it did, it works by slowly releasing chemical compounds. Let's say a gear tooth, you cannot do a proper blasting, so you need to clean it only, then you have to apply a VCI. So VCI will do what? It will slowly release the chemical compound within the sealed airspace that effectively prevent the corrosion. Chemical corrosion. Now we'll read different types of corrosions. Chemical corrosion. Chemical corrosion may occur in environment and product cleanup tanks as well as chemical storage facilities. So wherever there is, this is not so important. This is for your knowledge only. You can read it for your knowledge because this is required. If you only ask for going to crack an exam, maybe you can crack the exam because already I have highlighted the points. But other points also you need to read it for your own knowledge. So chemical corrosion may occur in environmental and product cleanup tanks as well as in chemical storage facilities. For example, a wastewater treatment tank operates by adding heat and or concentrated sulfuric acid to the water to break the emulsion of the oil and water. This is called chemical corrosion. Concentration cell corrosion. Concentration cell corrosion may occur with the steel tank bottom in contact with electrolytes that contain different substances of the same substance in different amount. It happens when you are using what is the product, that depends upon your corrosion. Corrosion always happen. First thing is the product, because product is direct contact with the bottom plate or cell plate. Then environment, temperature, that is different. Product quality, what type, chemical product, corrosive product, normal, acidic product, alkaline product. That product depends how the corrosion will happen to the bottoms. Concentration cell corrosion will cause pitting and may result in significant localized metal loss. Pitting of a base metal tank bottom may occur at a range as high as 80 mils to 2032 microns per year. This is only for information, no questions. Oxygen cell corrosion. Oxygen cell corrosion may occur when a surface deposit, mill scale or crevice or a crevice creates a localized area of lower oxygen concentrations. Galvanic cell corrosion. Hot rolled carbon steel, typically used for construction of petroleum storage tanks, is covered with a thin layer of oxide called mill scale, which is cathodic. And as I told you last slide, if you remember, this galvanic cell corrosion happened for the mill scale. Mill scale is always cathodic, which is cathodic to the base metals. In presence of corrodants such as dissolved oxygen and electrolyte, the galvanic corrosion couple forms of breaks in the mill scales and accelerated to the corrosions. Okay, these are all for info. Erosion, corrosion. Might be you know the difference between erosion and corrosion. Corrosion is a normal degradation of material, but erosion happens when there is some external forces there. Okay, a flow is there, and due to the flow, this happens, and this is called erosion. Erosion corrosion may occur in wastewater treating or mixing tanks where soil or small abrasive aggregates is present. To a lesser extent, erosion corrosion can also occur to a tank mixture in crude oil storage tanks. Erosion, if you will see, stream flowing and the rocks in the stream, you see there are line marks, okay, in the rocks, that we call it erosion. Okay, but if there is a still water in the pond and those areas it is corroded, that is called corrosion, because there is no flow. So that is the difference, to understand it easily. Fritting related corrosion. Fritting related corrosion may occur in hydrocarbon service in the bottom and external floating roof tank. Fritting means friction. Okay, so top floating roof, if there is floating roof, means it is not completely fixed. Okay, and it do a friction type of movement. So that friction movement can do a corrosion. So that is called fritting related corrosions. Generalized or localized pitting corrosions. Two common types of corrosion found on tank bottoms are general and localized pitting corrosions. In general corrosion, thousands of microscopic corrosion cells occur on the area of the metal surface, resulting in a relatively uniform metal loss. In localized pitting corrosion, the individual corrosion cells are larger and distinct anodic and cathodic areas can be identified. Stress corrosion cracking. Stress corrosion cracking has been identified in tank storage fuel grade ethanol. So you have to remember, one closed book questions was asked one time. Stress corrosion cracking only came when the product is ethanol or methanol. That you need to remember. If the product is ethanol or methanol, then stress corrosion cracking will come. That we need to remember. Rest of the things is for your knowledge. You can read it for knowledge. Okay. Determination of a need for tank bottom lining. When you have to decide you need a lining, as I told you in the beginning, lining decided as per the design criteria. What is the temperature, humidity, product used in the tank. Lining usually decide for the new tank and for the existing tanks. For the new tank, at the beginning, if we need any additional lining application, we have to decide at the time of beginning, or the designer will decide and he will instruct to put the lining. Or when it will come for in-service inspection, APA 653, at that time we will inspect the wall thickness of the bottom plates and find out what are the desired thickness is achieved or not. If it is achieved, then we have to think for whether we need what is the corrosion rate expected and how much the corrosion rate is happened. Okay, you remember the corrosion rate? The year of T previous, okay, T actual, T previous, and number of years. We divide and we find out the corrosion rate. Okay, so based on that, it is decided whether we need a lining or not. If you remember, I told you 655. This is no code. Don't think 655 is a code. 655 is, to remember you, 6 mm for the bottom plate, 5 mm for the shell plate, and 5 mm for the roof plate. That is the minimum thickness required for new construction of the tank. And 2.5 mm for bottom plate, 2.5 mm for shell plate, and 2.3 mm for the roof plate. That is the requirement as per APA 653 for in-service tanks inspection. If it is less than that, we need to replace it. That's why I told 655 and 2.5, 2.5, 2.3, 0.1 inch, 0.1 inch, and 0.09 inch. So that is as per 653. So let's read it. Storage tank bottoms are generally fabricated from carbon steel and plate selection that are typically 6 mm thick, as I told you. This is APA 650. Okay, there are questions. Minimum requirement of the plates. Annular bottom plate of storage tanks frequently have thicker plate section ranging from 0.25 inch to 1 inch, means 6 mm to 25 inch. Annular plate, I hope you remember, all annular plates are butt welding only. Okay, this is the ring, annular ring, on top of which the shell plate is placing. The bottom plate selection and the attachment fillet lap welds are intended to function as a membrane and prevent leaks. Okay, so this is the minimum requirement. If it is less than that, we have to go for a lining. Okay, lining of corrosion protections. Here it is saying about APA 653, that is 2.5 mm, as I told you before sometimes. So this is a question. Usually they ask in open book or closed book questions, but this is a closed book question, so you have to remember this one. This one is closed book questions. Many times they ask. If the minimum bottom thickness at the end of in-service period or operation are calculated to be less than the minimum bottom renewal thickness given in APA 653 or less than the minimum bottom renewal thickness providing acceptable risk as determined by RBI assessment as per APA 653, the tank bottom shall be lined, repaired, replaced, or interval to the next internal inspection shortened. Okay, so this is the requirement. If something is found, then either it should be lined, or it should be repaired, or it should be replaced, or the interval of next internal inspection is certain. Okay, what is the minimum requirement? Less than that, we have to reduce the internal inspection schedule. Tank foundation. We have read about the tank foundation in 650. We have also read in the 653 and 652 also. So the foundation must be adequate to prevent excessive settlement of the tank. Because if it will excessive settle, what will happen? If uniform foundation support is not provided, flexing to the tank foundation can result to the tank filled with emptied, and flexing occurs all steel bottoms. However, excessive fixing of the steel bottoms may cause internal bottom lining to crack. If there is any lining we did in the bottom and downside of the bottom, let's say this is the tank foundations and this is our tanks. If there is a settlement and you do some lining here and there is a settlement here, so this lining can break. That's what it is saying. Tank bottom lining selections. So tank bottom lining are generally divided into two classes. Already we read it. With DFT less than 20 mils is called thin, and DFT more than, equal or more than 20 mils is called thick film. Okay. So these are some of the inorganic zinc and zinc silicate lining where we apply it. Inorganic zinc, also known as zinc silicate, is a type of coating that are used to tank lining of ethanol and methanol storage. As I told you last times, you have to remember for ethanol and methanol services, it is usually open book questions. Usually we use inorganic zinc or zinc silicate coatings. Inorganic zinc or zinc silicate is different from organic coating in many aspects and typically applied at 3 mils to 5 mils. Okay, 3 mils to 5 mils. 1 mil is 25 micron, I told. 3 mils to 5 mils dried DFT. Okay, and for this one you need a surface preparation is SP10. This is usually sometimes open book questions. Thin film tank bottom lining. Thin film tank bottom lining system are frequently based on epoxy and epoxy polymer resins. For that one, you need SPA8 should be given consideration when designing and installing a thin film lining system to steel bottom plates. Experience has shown that when properly selected and applied to properly prepared surfaces and not damaged, the life of thin film lining can be greater than 20 years. This is a closed book question. Please remember what is the life of thin film coating and what is the life of thick film coating. Must be it is there somewhere, 25 to 30 years. Okay, maybe in the next slides. Okay, thin film is 20 years, okay, and the thick film is 25 to 30 years. That is a closed book questions. APA 653 only allow the bottom plate thickness to a minimum of 2.5 mm, that we know. Thick film coating, thick film reinforced lining may be used in the bottom plate for both new and existing storage tanks. Some thick film linings can be built up to 100 mils, okay, in a single coat. The DFT can be go up to 100 mils or 2540 microns, okay. So reinforced thick film tank bottom linings. There are currently two systems. There is one thin film, one thick film, another one is reinforced thick film. What do you mean by reinforced? Reinforced means you have to put some of the additional substances downside of the thick film. Okay, that is called reinforced. Fiberglass is a FRP, must be you know FRP. We are putting some FRP, then on top of FRP we are putting a DFT layer. That is called reinforced. Okay. So fiberglass reinforced plastic laminated and reinforced thick film linings. FRP laminators and reinforced thick film linings are methods to extend the life of this type of steel tank bottoms. This material may be applied to one coat up to 20 mils over a blasted and primed bottom that greatly reduce their installation cost. Okay. So what is the advantage? Advantage of thick film lining. Systems are designed to optimize the lining structure capability and performance. Additional service life of the existing tank bottom due to the reduced minimal thickness allowed remaining. Disadvantage, initial cost is typically higher and systems are more difficult to apply than thin film system, and thick film reinforced systems must take additional safety precautions, work around glass mat and chopped fiberglass materials. Circumstances affecting lining selection. As I told you, there are many circumstances that affect the lining systems. You will not find any question from this one. Okay. These two only for knowledge. Temperature and product quality. How the temperature and the product quality, you can read it. Presence of tank internals. Beyond the location of the coating should be terminated on the reinforced plate not less than 2 inch from any weld. This is a closed book questions. Please remember. What is the requirement? Okay. The coating must be terminated on the reinforced plate not less than 2 inch. That is a closed book questions. If feasible, if it is suggested the striker plates, the coating should be performed before the plates are installed, leaving the weld areas of the field coating. If there is any weld area, then you have to overlap up to 2 inch. Flexibility for service change. Okay. A properly applied tank bottom lining may provide more than 20 years service life. 20 years, as we read it, it is thin film coatings. Okay. So, storing a particular product. A lining that has provided many years of satisfactory protection in one product may have inadequate resistance in a new service environment. But that depends, 20 years also depends how properly you applied the linings. So these are the requirements for construction detail that can impact the lining, stress, corrosion, cracking and ethanol storage. This you can read it for your knowledge. Surface preparation. Surface preparation you will get one question. Okay, this is must. Generally, abrasive blast cleaning to white metal finish SP5 is desired for any lining. Okay, abrasive blast cleaning to a near white metal finish SP10 is often specified in a minimum degree of surface cleanliness. This is minimum required. SP5 is the minimum. There is a question always they ask. Pre-cleaning, there is a question. Okay, open book questions. Prior to abrasive blasting, all hydrocarbon residuals such as oil, tar and grease must be removed from the area to be lined. Okay, this is another one question. Water quality, this is for your info only. Removal of dust, this is usually important. Follow OSHA regulations when using compressed air for cleaning surface. Vacuum cleaning method have been proven to be more efficient. Why they avoid compressed air? Because compressed air sometimes contains some foreign particles, moistures, oil. Okay, that's why they usually suggest when you use compressed air, check the dew point. Okay, vacuum cleaning methods have proven to be more efficient. ISO standard 8542-3 may be used to determine the effectiveness of cleaning methods. Temperature and humidity, there is a question usually they ask for the lining applications. The temperature of the steel surface should conform to the lining manufacturer recommendations, application and curing range. As a rule, the surface temperature must be at least 3 degrees, same like painting requirements, okay, from the dew point temperature. And the relative humidity should be below 80%. Okay, the humidity should be below 80% and surface temperature where the lining will be applied, the dew point temperature should be 3 degree higher. This is a question you remember. This must will come in the closed book questions. Very possible. Lining curing. Lining curing, usually there is a question. Improper application and inadequate curing time are major cause of premature lining failure. The proper curing condition should be ensured to the full duration of the cure time. The proper condition for curing and lining may be accomplished by, this is the requirement, circulating warm dehumidifier air in accordance with the lining product manufacturers. Okay, so this is the requirement which they are mentioning. Inspection, there is a question from inspection you will get. Okay, we'll read on the slide, next slides. The lining installation should be inspected throughout the all phase of work and upon completion of the work. When they say all phase, before doing the blasting, after the blasting, during the application of lining, after application of lining, do some test, and if it is okay, then we can say the inspection is complete. Qualification is a question. Please remember, this is most of the time they ask these questions. What is the qualification of an inspection personnel for checking the lining? All lining inspectors should be either NACE or SSPC certified or should have demonstrated a thorough knowledge of coating and lining practices, procedures, inspections, testing and documentations. Okay. Film thickness. Inspection shall verify that all lining is applied. Wet film thickness measurements are being made for each coat in accordance to ASTM D4414. So this is the film thickness requirement. Lining discontinuity, we have to do a holiday testings, and whatever the requirement of holiday testing is usually a open book questions, no need to remember. Holiday testing of thick film lining shall be performed with a high voltage detector in accordance to NAS SP0188. Holiday testing of thin film lining should be performed with a low voltage 67.5 volt, low volt, more than that is high voltage, with a wet sponge detector. When testing with high voltage detector, it is important that the voltages are properly set in accordance with the manufacturer recommendations, bolts per mil and the film thickness properly measured and specified thickness, otherwise damage may occur with the testing operations. Then evaluation, repair and replacement of existing linings. A properly selected and applied tank bottom lining should have expected to provide minimum service life of 20 years. Minimum service life is the thin film lining. Okay. In some cases, as I told you in the earlier slides, thick film laminators provide 25 to 30 years. Thick film is 25 to 30 years. Lining repair and replacement. The term repair of a lining is typically used when either portion of the lining will be replaced. This is a open book questions. The term repair of the lining is typically used when either portion of the lining will be replaced or when all or a portion of the lining will be top coated. This is Repair, but replacement is used when all existing lining is completely removed. So replacement and repair. There is a question in the exam sometimes from open book. Okay. Health safety and standards you have to use as per the OSA 29 CFR 1910.13D and OSA 2254. So usually what happen? These are the most covered areas for tank linings, and I have highlighted those questions which will come in the exam. I am pretty confident whatever I have highlighted you will get at least 4 to 5 questions. Total 4 to 6 questions are coming. You will get 4 to 5 questions, or maybe most of the 80% questions whatever I have highlighted here you will get in the exam. But other areas where I told to read it for your reference, you can read those for your own knowledge and reference. So many thanks friends for watching the video. I hope you share these videos with your friend and help to grow this channel. Please like, subscribe and comment to the videos, and many thanks for your time to watch this video. Thank you.